See, this is the clue to jump right in my conversation. Okay? This is what I said the last time. There'll be certain things I say that will sound like it ends in a question, okay? If it does and I stop talking, okay, that's your key to jump right in. Yes, right here. Kyle?
Observation.
Okay, observational study, yeah, we're not going to try and get in the middle of this, are we? We want to see this in its natural state. Okay, so tell me more. How else am I, we got to have a plan to collect the data though, too, right? We're going to observe, okay? Any other thoughts? Yes. Who is this? Filomeno?
For the observation, we're looking for the average time that the customer waits to drive through.
Okay, so we're going to collect, and we're going to get average time. That makes sense. We get an average, we've got to get something to average then, right? We have to absolutely have a bunch of times. Okay, other thoughts about what we're going to do in terms of how we're going to design it?
Well, we can kind of see, like, because there's like dinner rushes and stuff like that, you know, in restaurants, we can see how long people are waiting over there in those lines, you know, like morning, lunch, and dinner and stuff like that, you know. And I'm sure it gets busy around like 3 to 7, you know, I mean, everybody's going to get food and stuff like that.
Okay.
So people are usually waiting longer during those times than like around like 2 in the morning, you know what I mean?
Well, 2 in the morning, they probably won't wait long. That's true.
Yeah, you know.
Okay. Other thoughts? What are we going to collect? How are we going to collect the data? Yeah, who's in the back? There's Samantha? Okay.
You have to have like a definite starting and ending point, like when you start the time and when you end your collection of how long they're waiting.
Are you talking about we're going to do this for 2 weeks, or you mean you're talking about like,
No.
okay, Nick drives up in a car and he says, here's my order, I hit the stop clock, and then when I hand him the order, that's the end of the stop clock?
Right, you have to determine like what is actual waiting time for them to be.
So how would we define waiting time then? Yeah, good question. I mean, I think it's, yeah.
So what a good way to do it would be is to randomly pick out like a bunch of little sections of data and figure out how long it takes the people to go from, like, say, once they've ordered to get to the end to get their food,
Right.
and then get a bunch of your data and see when people start getting like fussy, like starting to complain. So say that people aren't complaining at 1 minute. Say it takes the average between one, you've got 58 minutes or 58 seconds, 1 minute and 3 seconds, and then at like 1 minute and 30 seconds, people start getting like iffy. You've got a few people, and then at 3 minutes, you'd have a ton of people that would be complaining about the time that it would be taking.
And I suspect at 5 minutes, you have a lot of food and no people.
Right.
So they've all left. Okay, but let's not lose sight of the question that we're trying to answer, okay? This is, let's say this is a timeline, I don't know, this starts at 0 seconds, and I think the stopwatch probably starts when the order is complete, right? In other words, you drive up and Andrew says, I'd like, a Big Mac, fries, and a Coke, okay, and that's it, so the clock is now ticking, okay? And at some point, it stops by the food comes out the window and it's handed to you. That stops, okay? But the question at hand for us is, we want to offer a 50% discount to anybody who goes beyond some specified time, right? In other words, and so the question that we have to figure out is, where are we going to draw this line that says, here's the threshold?
Like Jimmy John's, like they know exactly like what their average time it is to get like food out to those people that have ordered.
Okay.
So then they know if they're going over, then there's something wrong. They're slacking, or
So is our threshold going to be the average time?
correct. You just
Why,
passed.
Marlon?
No, it shouldn't be the average time, because that means you're gonna be giving discounts to 50% of the people.
It'd be tad over.
Yeah, if you make the threshold the average time, then half the people are going to be under the threshold, and you're going to wind up giving 50% discounts away to the other half of the people, right? So we got to figure out what the threshold is. Where should the threshold be? So how are we going to collect data to figure this out?
Between
know how we're going to time them, but I want to know a broader question. Yeah, broader. Okay, Vesta.
Possibility of like a survey to ask people like what would be your average, like your breaking point of how long you would wait, and then take like the highest of that. So if someone was like, I wouldn't wait 5 minutes, and 5 minutes is kind of like the consistent answer.
So are you and Kyle in the same discussion group back here?
We were
If
kind
he's doing an observational study and you're doing a survey, you're doing both?
well, we threw those back and forth that it could be.
Okay. Fair enough, okay, so we can ask people, okay, certainly ask people what's their threshold, okay, so maybe a survey, right? Also, here's my jaded opinion on surveys, people say things that they don't, people say stuff and their behavior doesn't always follow it. And what I mean by that is that, you know, when somebody says, how do you like this new product? You know, and I say, oh, this is really great. You know? On a scale of 1 to 10, how likely are you to buy this product? And everybody in the United States is pretty polite and they say, well, I'm a 7. They never buy the goddamn thing. So, and it's a good idea because you have to maintain contact with the customer, okay? Surveys are a good idea. But you should be somewhat jaded about attitude versus behavior. When people tell you their attitude, it does not necessarily mean that that will carry through with their behavior. Does that make sense to everybody? That's just the way we are, okay? Because the difference between attitude and behavior is to get from attitude, I have to reach in my wallet somehow to get to behavior, okay? And people get stuck right here, okay? They said, I can be very nice telling people what I intend to do, but when it comes to laying money down, sometimes people get a little fussy, okay? So other thoughts about exactly how we're going to collect the data, okay? So we're going to collect it from one store, many stores, we're going to collect it every day of the week, are we going to how are we going to collect the data? Any other thoughts? Yeah, Samantha, again.
I was just gonna say about the time again. I think that maybe if it's not necessarily the average time, but the times that are at the higher end of the spectrum, because then you would.
The threshold, you mean?
Yeah, because then you would be taking into account the lower times and the higher times, but you kind of want to drag it out as much as you can, otherwise people would still be getting discounts left and right.
Well, yeah. If I own the McDonald's, I don't want to give a 50% discount to every other customer, right? And so if I set the threshold too low, I'm giving too much money away, too many discounts. When I set it too high, then it's of no use, okay, other than just maybe PR. In other words, if I set the threshold at, 6, 7 minutes, you're all going to drive away, okay? So I might have to give it away a little bit, but you're absolutely right. It ought to be probably, I think, at the kind of higher end. But again, how are we going to collect the data? Where are we going to collect it? What factors are going to affect this study as I'm collecting the data?
Places with higher traffic and lower traffic?
Higher traffic, lower traffic, absolutely. There are probably parts of the day where we get jammed up, right? In other words, around noon time, maybe around supper time, maybe around breakfast time. What are other factors that we have to worry about if we're collecting this data? Yeah.
Our group also said that maybe like how well prepared each like chain was or each restaurant. Like, do they have the food? Are they out of anything? Like, is it going to take them longer? Like, what do they actually have prepared?
Absolutely correct. Other than the food, what's another factor inside the restaurant that is going to just play into this? Huh?
Like, how many workers do you have? Are you understaffed? Is there enough people?
Kane, your thoughts?
People that actually come into the store.
Number of people that come into the store. Yeah, what were you going to say, Megan?
What location you're in, if you're in a city or in a rural area.
Okay. Okay. All of those are factors that could affect the level of training of the staff, how good the staff is actually. Not only how many I have, but how good the staff is, okay? Okay, so what's the population that we're trying to understand here? When I say, we talked about the word population last time. What's the population I'm trying to understand?
Everyone who comes to the restaurant?
Well,
60 and older.
well, you're talking about population literally here. In other words, thinking of it as people. I'm saying, what's the population of data, of information? Yeah, Kane?
Drive-through customers.
The waiting time of drive-through customers. Yeah. In other words, the customers that are coming drive-through. That's the literal people population. But the population is really the population of what? All waiting times where? Maybe all across the U.S., right? In other words, whatever it's going to be. It doesn't seem to me that this is a problem that McDonald's can say, okay, Nick in your store, Marla in your store, you guys decide what the threshold is. That's not going to work for a national chain, right? You can't have Nick having a threshold of 2 and a half minutes and Marlin having a threshold of 3 minutes, that's just not gonna work. You're gonna have to have some consistency. So they probably are talking about having the population be geographically, certainly in large geographic region, maybe it's not all the United States, but most sections of the United States, okay? Because McDonald's is not gonna have, you're not gonna be able to make a claim, and there's 6,000 versions of the claim, right? That doesn't make any sense. What's the variable of interest? And the variable of interest here is what? The waiting time, right? That's what we're interested in. The population, I think, is the waiting times, maybe it's all waiting times across McDonald's in the US. What's the sample? What is the sample in this going to be? Somebody describe to me how you're going to get your sample of data. What's the difference between population and sample? I'd like to understand the population of all waiting times for all McDonald's all across the country, but that's pretty expensive, pretty expensive.
It would have to be the people that you caught during your observation, because you can't possibly check everyone that goes through. So a
Fair
smaller
enough.
portion than what? A smaller portion of the customer base as a part to the whole.
And what does that mean?
Not all of them.
Okay.
He's saying, how do you choose those?
How do I do it though?
You could choose restaurant locations that get different levels of commerce, or just have different social groups within them.
Okay, different geographic locations, different
Cultural and geographic.
size of restaurants, traffic, okay. Yeah, I mean, I can't collect the data probably from all 6,000 restaurants because I'm gonna tie up too many workers doing that. Yeah, okay?
You can maybe just, I mean, Bill stores have a number, there's like the first one and the last one, you do like maybe your 50th store, maybe you have your 100th store.
Okay, might wanna do that, okay? Oh, my questions went away. All right, so, what's the inference? What do I mean by inference? That's the interpreting the data. I go from analyzing my data to making an inference to the broader population, which is the behavior of all stores. The inference here that we want to make is that I'm going to somehow discover what waiting times look like at all McDonald's, right? I'm going to figure out maybe an average, or I'm going to know what the distribution is. Remember the graphs I gave you last time? You know, in other words, I like to make a graph of what it looks like, what the waiting times look like, okay, and the data that I collect, okay? If I make a graph, and we're going to do this later, but let's say who had the mound-shaped symmetric graph last time? Anybody? Somebody in this group had a mound-shaped kind of symmetric graph. I don't know whether it's going to come out like that, or whether it's going to come out like this. In other words, most orders get serviced right here, but then there are some that drag on, you know, long ways. I doubt that it's going to look like that, right? That would say that there are very few fast orders, but most of them are slow. I know it's not going to look like this, even across, right? So I'm not betting on that one. I'm not betting on that one. Maybe the picture will look like this, or maybe it will look like this. Everybody understand why? Because you might have, you know, pretty standard orders here, but then somebody orders, you know, anybody ever see the old movie Jack Nicholson, 5 Easy Pieces? It's a great movie. Okay, you never get to see it. But Nicholson goes into a restaurant, and he's a motorcycle rider, and I think he was Dennis Hopper. And there's a scene in the movie, and it's about 3 in the afternoon, and Nicholson wants 2 pieces of white toast. That's all he wants. And he goes in a restaurant, and he says to the lady, I'll take 2 pieces of white toast, no butter, no jam. And she says, well, it's not breakfast time. We don't serve toast except for breakfast time. And so Nicholson, I don't know if you like Jack Nicholson, but he gets really kind of pissed off and upset and nasty, and he gets a snarly look on his face, and he says, well, just bring me the toast and a cup of tea or something. bacon, lettuce, and tomato. But I don't want any bacon. I don't want any tomato. I don't want any lettuce. And I don't want any mayonnaise. Okay? And I'd like to have it soon. So give me my BLT. So maybe there are orders like Jack Nicholson every once in a while, okay, that, you know, are special orders that take a long time. I don't know what it's going to look like. So we're going to try and set our threshold when we figure this out somewhere over here, so we don't give away all our money, but yet we don't upset everybody, okay? Because the person who's getting this order is screwing up who? The person behind them, okay, are going to be upset. That's it. Order still goes back to say, I think we talked about that a lot, okay? So at any rate, just a quick summation of this before we go on to try and put this in play with other things, okay? One of the things that I think it was McDonald's did was they started out kind of slow. They said they picked one drive-through in Dallas, Texas, and for 7 consecutive days they actually timed the orders, and they had a stopwatch. They had 2 synchronized stopwatches, and the stopwatch was started when the order was taken, and it was actually stopped when the order was delivered. The food was handing to the people, and at the end of the 7 days, they had about 2,109 pieces of data, which were the waiting times, okay? Now, if I only did that for one store in Dallas, I'm not sure to what larger audience I could infer that that was data that represented a large audience. Maybe I could infer for all of the Dallas stores or something, or maybe all of the stores that had, like you said, you know, this size of traffic and staff, training level. But the idea was, I think that they actually collected this data in one store, tried to figure out how it worked, and then, you know, kind of expanded on from that, and were able to kind of get a sense of all their stores. So, all right, so to wrap up, let me look